Welcome to today's presentation. My name is Howard Chomba. I'm the hoist mechanical engineer at Main and West Body. So we'll go straight to the keywords for today. So the first one is hoisting. So hoisting is the process of moving loads along a vertical shaft up and down a vertical shaft. The second keyword is a conveyor. So a conveyor, in our case, a conveyor belt. This is a continuous loop of rubber which is supported on pulleys and driven by a motor. So this one moves material from one point to another. Then the other keyword is ore, which is our main business that we do at NFCA. So ore is a natural rock that contains valuable minerals. We move to crusher. So crusher, it's a machine that we use to reduce the size of rock to a smaller size for further processing. We move to winder. So winder is a mechanical machine that's used to drive either the conveyances such as skips and man cage from surface to underground and underground to surface. Then we go to the skip. So the skip, this is a bucket where either waste rock or ore, it's the one that we use to transport from underground and to bring to surface along the mine shaft. Then we've got the man cage. So the man cage is a conveyance that we use to transport personnel and material from between underground and surface. Then we've got winding ropes. These winding ropes, these are steel wires that connects between the winder and the conveyance. So we've got different types of winding ropes. We've got, like at main body, we're using a full oct 45mm rope on our man cage. Then we're using a 53 compound strand rope on triangular strand on our rock winder. Then we've got rope examination. So rope examination, this is the process of visual inspection of the winding rope, which is done by competent people. In this case, the riggers. They thoroughly check the ropes for any damages and also to check how well lubricated the ropes are. Then we've got waste rock. So waste rock is just the opposite of ore. It is basically a rock which does not contain any valuable minerals. Then we've got a ventilation fan. So ventilation fans in underground mining, these are equipments that are used to supply fresh air underground and also to remove hazardous gases, dust, and to also maintain the temperatures for the workers working underground. Then we've got gearboxes. So gearboxes, these are mechanical systems that transmit torque and adjust speed between the prime mover, such as maybe a motor, an electric motor, and the driven. Then we've got the guide rail. The guide rails or shaft guides, these are rigid tools that are made out of steel, which guide the conveyances when they're moving along the shaft. Then we've got attachments. So the attachments, they link the hoisting rope and the conveyance or the skip. Then we've got motor. Basically, a motor, it's a machine that converts electrical energy into mechanical motion, such as torque or rotation, so that it can drive an equipment. So the other keyword is compliance and dynamic test. Compliance and dynamic test is one of the important tests that are carried out on the winding plant. So compliance refers to the test which verifies if the safety devices, the brakes, and the control system is operating. These things are meeting the regulations. Then dynamic testing refers to the testing of these systems to see how they're going to operate in a real-time scenario, to see if they're going to respond accordingly. Okay, I don't know what's happening. I'm unable to see the other keywords here. Then this is how our department is structured. So we've got our manager, who is Chinese. Then after our manager, we've got two superintendents. So one of our superintendents is a production superintendent. Then the other one is an engineering superintendent. So under the engineering superintendent, we've got the hoist mechanical engineer. So the hoist mechanical engineer has got the winding foreman and his subordinates. He's got the hoist fitter foreman and his subordinates, and also the conveyor fitters under him. Then we've got the hoist electrical engineer. The hoist electrical engineer has got the hoist electrical foreman and the electricians under him. He's got the distribution electrical foreman and his subordinates. Then we've got the pump mechanical engineer. So the pump mechanical engineer has got the pump fitter foreman and the pump fitters. Then we've got the underground electrical engineer, who is in charge of the pump electrical foreman and his electricians, the instrument foreman and the instruments, and the underground electrical foreman and his subordinates. Then we've got the crushing mechanical engineer. The crushing mechanical engineer has got the crushing foreman and the crushing fitters. He's got the boiler maker foreman and the subordinates. He's got the rigger foreman and the rigger subordinates. Then on the production side, we've got four mine captains, three general mine captains, then we've got one shaft mine captain who is in charge of the timbermen, the shaft maintenance, and taking care of the shaft bottom. So the other three mine captains have got shift bosses. So these shift bosses, which are 6, they are responsible for the cage tender, the crushing PIC and the operators, the skip men, the dislodging crew. We've got the open pit pump operators, control room operators. Then we've got a conveyor foreman who supervises the drivers, the conveyor operators, side cleaners, and vibrator operators. Then we've also got the cost controller and subordinate, the materials coordinator. So we've got a labor force of 232 people at Main and West Body Operations Department. So we start with the introduction. Well, the operations department is the heart of the mine, and it plays a critical role in ensuring production targets are met. The areas of responsibility for the department are: number 1, ore and waste transportation. So ore and waste transportation all the way from underground all the way up to concentrator. Then we've got mine winding. So mine winding, that's the transportation of people and material using the man cage between surface and underground. Then we've got ventilation fan maintenance. As a department, we're also responsible for the maintenance of the exhaust fans that are responsible for the ventilation of underground. Then we've got the dewatering and pumping section. So as a department, we're also responsible for the removal of water from underground and also the removal of sludge from underground. Then we've got power distribution. So when power comes from CEC, we're the ones that receive the power. We step down and distribute to the whole plant at Main and West Board. My roles as the hoist mechanical engineer, I supervise the maintenance works on the winders, the skips, the man cage, the conveyor belts, and also the ventilation fans to ensure they are available for production. I also supervise the installation of mechanical equipment. My other responsibility is to ensure safety management and compliance in accordance with company regulations and MST, which is Mine and Safety Department. So here, we'll start with ore and waste transportation. So this flow chart is showing how waste and ore is transported from, how it moves from underground all the way up to concentrator. So we've got tips underground at 500, 700, 878. When material, either waste or copper from these tips goes to 920 crusher. Once crushing is done, there's a common pass which leads to 972 loading station. That's where the skips are loaded to bring the material to surface. So when the material comes to surface, it's transported to concentrator using the conveyor belts, and also on the waste dump site, we're taking waste using some dump trucks. So in this photo, it's showing the pictorial view of the primary crusher, which we have at Main Body. This crusher, whose main purpose is to reduce the size of the rock, so both waste and ore passes through this same crusher to reduce the size. Then the crusher is driven by a 200 kilowatt motor. Then on the repair works that are done at crusher, we're changing the liners, which include the concave liners, which are in the top shell, also the bottom liners, bottom shell liners, then also changing the bushes in the bottom shell, which are made of bronze from time to time. Then we come to the loading station. So at the loading station, we've got 2 loading boxes, which are fed using fingers, which are operated using a pneumatic system to feed into the flasks. So again, this ground from the flasks or the loading boxes is fed into the skips using a sector gate, which is operated using a hydraulic system. Then on the major works that we do there, we are basically changing the steel liners inside those flasks and just maintaining the hydraulic station. We've got a picture showing the skip. So this one right here is the skip when it has come on surface and it has tipped the material. Here there is a bin which we call 50 ton, which has got a capacity of 50 ton. That's the first part. When ground comes from there, it goes into the 50-ton bin. The skips, like I mentioned, they're the ones that are responsible for transportation of waste or ore from underground to surface. So the maximum speed, these skips, the speed that MSD has allowed us to use is 10 meters per second, but it can move beyond that. But speed that we have been permitted to operate it as is 10 meters per second. Then the capacity of material, it carries 17.4 tons. Then on average, in a day, we can hoist 330 skips. But if there are no delays, we can even go all the way up to 400 skips in a day. Then after a skip works for 55 days, we usually remove it from the system so that we can thoroughly check it and do some repair works, which include changing the tires on the skips, changing the bronze liners, and just generally checking the skips for any defects. So the skips are moved by a double drum winder. These skips are moved by a drum winder which is powered by a DC motor. The double drum winder, the drums are fitted on a single shaft, which are used primarily in mining hoisting loads from deep shafts. It uses 2 drums to wind ropes for hoisting, with a conveyance on each rope for balanced lifting or lowering. So this is the configuration I was talking about. So the 2 conveyances, when one is going up, the other one will be going down. Just like that, they'll be balancing each other. Then we've got the winding drum. So one end of the rope is fixed on the winding drums, while the other rope passes through the sheave wheel. The sheave wheel is mounted in the headgear. So it passes through the sheave wheel and then attached to the conveyance. So the winding plant has got statutory jobs that are carried out, and these are governed by the mining regulations, which are contained in the 400 series. So here, the first item that's there is weekly rope examination. So every week, riggers physically inspect the rope to check for any broken wires and also to check the condition of grease. Then we've got also weekly winder maintenance. So during weekly winder maintenance, the fitters and the electricians, we isolate and switch off the winder to check for any defects and carry out repairs where necessary. Then we've got weekly shaft examination. So during weekly shaft examination, we check the steel work in the shaft, we check the guide rails, the shaft beams, the clearances to ensure they are within acceptable values, and rectify potential or any obstacles or obstructions that might be in the shaft. Then we've got rope cut. So according to the regulations, every 6 months, we're supposed to cut a rope sample from the socket end 3 meters. So like today, we're even doing the same job on the man cage now. So when that rope sample is cut, a sample is prepared and taken to an independent company where they carry out a destructive testing. So this one is done in order to test the breaking force of the winding rope to ensure it's within the acceptable values. So if at all we do this test and we find that the rope is not okay, that means that we need to change the rope. Then we've got compliance and dynamic testing. So here we try to verify all the safety devices, the brakes, the control system to ensure they meet regulatory standards. We also try to test these systems in under operating conditions to ensure they function properly in real-time scenarios. So here we test the brakes under load by how the distance it will travel before the conveyance stops. We also check for the overspeed. Then we've got electromagnetic rope test. So EMRT is also done every 6 months. So this one, I think I'll show you a photo. In this picture, it's showing how the machine is set up when carrying out EMRT. So the shaft is closed. We put a platform, a working platform. Then we put that machine on the rope. So as the winder is moving, That machine will be detecting internal and external defects in the wire, because just inspecting with the eyes is not enough to see any potential damages of the wires. So this one helps us a lot in detecting faults in the wires that we can't see with our own eyes. Then we've got non-destructive testing of attachments. So every 6 months, those attachments that are attached, the link between the rope and the cage, they have to be tested every 6 months for any flaws, any damages. Then we've got rope change. So according to Zambian laws, every 2 years, you're supposed to change the winding rope. So if the rope is still okay and it has worked for 2 years, what you do is you carry out the test. You do the EMRT test. You carry out compliance test. After those tests are done, you need to write to the Mine and Safety Department to ask for rope life extension of 6 months. Then shaft maintenance. So like I said, we've got an odd mine that side. So we're carrying out a lot of shaft maintenance works where we're changing guide rails, where we're changing the main beams, we're changing the cross beams, the shaft panels, the ladders, just to mention a few. Then we've also got the dailies now. So every day, the fitters and the electrician, they need to thoroughly check the conveyances. They need to check the skip, they need to check the winding rope, they need to check the attachments, and to check generally the winding plant to ensure it's okay. Then we've got the conveyor belts. So in this picture, it's just showing a conveyor belt. So like I mentioned, ore and waste, when it's tipped on surface, we transport it to concentrator using conveyor belts. So we've got 4 conveyor belts in the department. We've got the SC1 belt, SC2A, SC2B, and that SC3. So SC2B is one of the longest belts in the company, I think. It's about 1.5 kilometers. So on the maintenance works, the major repair works that we do, we replace the rollers when they are worn out. We change the pulleys when we need to rubber line or change bearings. We're also changing the gearboxes. We're also changing the belt in case it's cut. If the cut is not very bad, we can put fasteners. But if it's very bad or maybe the belt has worn out over time, we replace those belts. Then also making belt joints, because the belt they come as 200-meter raw. So those belts, we were using hot vulcanizing or using hot splicing to join the belts. On this picture, it's just showing how the setup is when we're making the joint. So we've got clamps there, we've clamped the joint, but before we do this, we usually prepare the 2 ends. After preparing the 2 ends of the belt, we put some core rubber, then put them together. So it has got heaters there, and there's also a water jacket. So man winding, this photo is showing, this is the motor right here. We've got the winding drum, the brake calipers, the spring nest, the brake engine cylinder. For man winding, we're using a double deck man cage, which moves at a speed of the speed that we've been permitted by MST. The maximum speed is 4 meters per second. Then the lowest station or the lowest landing platform along the shaft is at 1006. So the cage moves from shaft bank up to 1006 meter level. Then the maximum permitted persons is 126, while the load 8,840 kg. So just like the skips, even the man cage is driven by a double drum winder. So we've got two winders which are in the same wind house, and we're using one single shaft for both the skips and the man cage. Then we come to the ventilation fan maintenance. So this picture is just showing one of our vent fans. This one was taken at #1 vent fan. The purpose of the ventilation fans are to supply fresh air underground, and also to remove the hazardous gases and dust, and to ensure the temperatures are favorable for our miners when they're working underground. So we've got 4 main exhaust vent fans at main and western body, which are number 5 vent fan, we've got number 1 vent fan, we've got east vent fan, and west vent fan. So in this picture, it's showing fitters carrying out maintenance. They're inside the ducting of the vent fan. They're greasing the motor. So every day, our electrician and fitter, they go around all the 4 vent fans to check for any abnormalities. Then on a monthly basis, we switch off all the fans. Every month we switch off. We do it one at a time, not all of them at the same time. And the way it is, at a time, 2 are operating. So sorry, 3 are operating. One is usually on standby. So when we do the monthly maintenance, the electricians will check the electrical system for any defects or for any problems. Then also the fitters will be greasing the fan motor. They need to check the holding down boards. If they are loose, they need to tighten. They also need to check the condition of the blades. If they're worn out, we need to change. Also to check if the fan is balanced. And finally, if it's not balanced, we have to carry out some balancing. All in all, operations department plays a very vital role in ensuring production targets are achieved by ensuring the equipments are readily available for production. Department also ensures personnel and material are transported underground and to surface on time. Thank you for your attention.